Alright guys, so this is our second video for our Flip the Classroom lesson on basic combinatorics. And in this video we're going to be talking about distinguishable permutations, right? So permutations, we want to associate that word with arrangements or orderings. And so right here we're talking about distinguishable orderings of elements that we are arranging. So right here we're going to say that for distinguishable permutations, if an n set, and we want to be clear here, an n set is going to contain n items. So right here we might say with n items. So if an n set contains n sub 1 objects of the first kind, n sub 2 objects of the second kind, and so on, with n sub 1 plus n sub 2 plus n sub k, where n sub k is the number of objects we have of the last kind, equaling n, then the number of distinguishable permutations of the n set is going to be n factorial divided by n sub 1 factorial times n sub 2 factorial times n sub k factorial. Okay, so let's try to decipher what we mean here with this definition with an example. So right here we have a couple of words, and right here we want to count the number of 9-letter words that can be formed using the letters that spell the word butterfly and bumblebee. So right here, first what we want to do is talk about what we mean by words. So when we're talking about words in this case, we're basically just talking about an arrangement of letters, right? So they don't actually have to spell a literal word. But right here, what we're going to do is talk about all the different arrangements or permutations we can create from the letters that spell the word butterfly. So right here, if we're talking about an arrangement or a permutation, we would say that we'd be doing that, determining that the number of permutations with a factorial, right? Right here we have 9 letters. Right here we have 2 t's though, and maybe what we can do to distinguish between the 2 t's is give them a subscript. So we'll call our first t t sub 1 and our second t t sub 2, right? And now right here, what we can say is that the number of permutations we're going to have is going to be 9 factorial, since we have 9 letters. But really, our 2 t's are the same letter, right? So if we're talking about arrangements of these 9 letters, we've actually repeated every arrangement because we could switch the 2 t's and get the same arrangement of letters. So right here, what we want to do now is take our 9 factorial and divide it by 2. And when we divide our 9 factorial by 2, we're going to do away with all the repeated permutations that we're going to get. So right here, that would give us 362,880 different permutations, right? But then we want to divide by 2 to do away with the doubled permutations. Take all this, bring it a little bit over. And right here, that's going to give us, in the end, 181,440 distinguishable permutations, where we can actually sort of tell that we've got 2 different arrangements, right? Because of course those t's are repeated. So when we have the 9 factorial, that's going to include all of the arrangements that we could sort of switch the t's for. All right, so right here what we want to do is take our original statement, 9 factorial divided by 2, and compare it to what we have up here, right? So really what we have is 2, right? Basically being the number of ways that we could rearrange our t's. And that's basically going to be the same as 2 factorial, right? So right here, the number of t items we have is 2, and that means we've got to divide by, right here, our 2 factorial. Now what we can also take note of is that for all of the other letters in the word, we only have 1 of that letter. So right here we would basically be multiplying by 1 factorial times 1 factorial again times 1 factorial again and again for all the different letters that we have here. Really, what that's going to boil down to is basically just a division of 2. Since 2 factorial is really just 2 times 1, and 1 factorial is basically always going to be 1, right? It's 1 times, really just the 1. So right here, 2 factorial is, of course, 2 times 1, which gives us 2. That gives us our denominator of 2. 1 factorial is just a bunch of multiplications of 1. And right here, we're going to get our 9 factorial divided by 2, giving us the number of distinguishable permutations as 181,440. So right here, what we want to do is apply this principle to determine all of the different distinguishable permutations we're going to get from rearranging the letters in the word bumblebee. And basically right here, we're not going to have to worry about all of the 1 factorials. So if something appears once, we don't have to worry about representing it with a multiplication of a factorial in the denominator, right? But we are going to want to worry about all the letters that appear more than once. So right here, for example, we've got B appearing 3 times, right? And that's something we're going to want to take account of in our denominator with a factorial. So right here, we're going to pause the video, and I'm going to let you guys give this one a shot, and we will come back and try it together in a second. All right, guys, so right here, we can see that we have our B appearing 3 times, right? So we have 3 of the B type of letter, and we have our E appearing 3 times as well. So here we have 3 of the E type of letter. So we want to take note of that in our denominator. Everything else just appears once, so 1 factorial is 1. We don't have to worry about that. Right here we've got the number of ways that we can rearrange the letters in bumblebee in general as being 9 factorial, right? And now right here we're going to divide that by 3 factorial times 3 factorial. 3 factorial is 3 times 2 times 1, so that's 6. So really we have 6 times 6, giving us 36. And we're going to take our 362,880 divided by 36, and that's going to give us 10,080 different permutations, distinguishable permutations, of the letters in the word bumblebee. Okay, so this is the end of the second video, and we are going to come back and look at combinations and permutations in our next video.